Alright, this video is going to show you how to use an area model to do division of multi-digit numbers. We're going to start off with one that will not have a remainder and then work our way up to one that does have a remainder and a 3-digit number for the dividend as well. First off, let's remember this. The 84 is your dividend. The 4 is your divisor. This is also the same thing as we think about 4 times what equals 84. So we are missing a factor. If we think about multiplication, we're missing a factor. So we have to try to figure out what the factor is that when I multiply it with 4 will give me 84. That's the way we think about division. So to get us started, first I want to take our divisor, which is 4, and I want to list the multiples of 4 so that I know what I'm working with. Okay, so I'm going to come down here and I'm going to list the multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32, and 36. I go up to about 12. That gives us a good set of numbers to use. Okay, so we're going to use an area model to do our division. Just a couple things to freshen our memory about area models. Multiplication is rows times columns equals your product. So rows times columns equals your product. For an area model, you have your rows and your columns, and that equals your product. So the product goes inside. So if I look back up here, and 4 times blank equals 84, 84 is my product. So 84 is going to go inside of the area model. My rows are 4, which is my divisor. It goes outside of the area model on the left, but I have no columns right now. I'm missing that factor. So let's go find our area model. So we said that our 4 number of rows, our divisor, goes on the outside. And I need to fill the inside with 84. I don't know how many times 4 goes into 84, but I can break apart the number 84 into smaller numbers that will equal 84 to get compatible numbers that I can divide with. By compatible numbers, I just mean numbers that we know, like 4 times 3 equals 12. So can I use 12? 4 times 5 is 20. Can I use 20 to equal up to the 84 that I need on the inside? So I'm going to look back at my list of multiples. When I look at this list of multiples, I want to find numbers that I can add together to get my 84. So I look essentially for numbers that end in 0. Those are the easier ones to add together. So I'm going to start with 20. So if I put 20 in my area model, that doesn't equal the 84 I need, but it gets me started. So I need 84. I've already used 20. So how many more do I need? 64. 64 is not on my list of multiples, but I could do another 20. If I use another 20, that leaves me with 44. I could again use another 20. That leaves me with 24. I could again use another 20, but if I look over here, look what's on my list, 24. So I can put 24 in my area model. If you run out of room, that's okay. You can just make your area model a little larger. So I put 24 inside of here. Now, the whole point, if you remember, was that the inside, which is the product, gives me the 84, which was what I needed to start with. 20, 40, 60, 84. That all equals 84. So now I need to find that missing factor. Basically, I'm answering these questions. 4 times blank equals 20. 4 times blank equals 24. Because according to our area model, the factors on the outside, sorry, that was wobbly. The factors on the outside multiply to give us the product on the inside. So if you don't know how many times 4 goes into 20 or 4 times what equals 20, we can go back to our multiples. How many 4s till I get to 20? 1, 2, 3, 4, 5. So it's 5. Well, luckily, I've used 20 several times, so it's 5 each time. The 24, if I go back to my multiples, 1, 2, 3, 4, 5, 6. Now, if you already know that 4 goes into 24 6 times, that's all you're asking yourself is 4 times what equals 20 and 4 times what equals 24. Okay? So if you know those, then you don't have to use your multiples list. Now, your quotient is all of this added together. These are called partial quotients because they're pieces of the whole thing. So if I add this together, 5 plus 5 plus 5 plus 6, that is 21. So that's a little blurry. 21. So my quotient is 21 because 4 times 21 equals 84. Okay, if you look here, here's some other examples of ways that you could have done the same problem. You could have used 80 and 4, broke it apart that way. That's actually the expanded form of the number. 4 goes into 80 20 times. 4 into 4 1 time. 21. You could have also done 40 and 44, which are numbers on your multiples list. 40, 44. So you could have used those, and you still would have ended up with 21 as your answer because 4 times 10 is 40. 4 times 11 is 44. So add those up. Your answer is 21, 4, 84 divided by 4. There's no remainder on this. So now I'm going to show you one that does have a remainder. So here we have another problem, still 2-digit, that does give us a remainder when we end up with our final answer. So if we think about our multiplication, it would be 5 times something equals 97. Now, we already know that there's going to be a remainder because our sense of 5s, we should know that the multiples of 5 always end in 5 or 0. This ends in a 7. So we should know there's going to be a remainder on this. Okay, so first we need to list our multiples. So we do 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. Once again, we're looking for numbers that will help us to create an area model with 97 on the inside because that's what goes inside of the area model, the product. So we want 97 in here. Our divisor is 5 because that's our rows, how many we have, and we're missing our columns. So if I look at my list, I want to find numbers that equal 97. Well, I know that 60 and 30 will give me 90. So I'm going to start there. So I have 60 and 30. But I have 7 left over because I know that 60 plus 30 is 90, but I need 97. So if I subtract that, it shows me that I need 7 more. Well, 7's not on my list, but 7's all I have left. So if I look for a multiple that's less than that 7, I have one. I have 5. So I can put 5 down. Well, if I subtract that 5, I get left with 2. When you get a number that is less than any of the multiples that are on that list, or you could think of it as less than your divisor, that is your remainder. So you put it in your area model and circle it because you are not going to have to divide with that. That is your remainder. So now we need to find the missing factor for these 3 pieces. So how many times does 5 go into 60? Well, if you're not sure, go back to your multiples and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The next number is 30. Count it. 1, 2, 3, 4, 5, 6. 5 is 1. So let me show you what that looks like over here. We said it goes into 60 12 times, 30 6 times, and 5 goes into itself 1. So if I add up my partial quotients, I get 19 with a remainder of 2. So my answer is 19 remainder 2. Hope that helps. 3-digit is the same way. You want to find numbers that equal up to that, but you also need to think about possibilities of the zeros and how those work. So let me show you an example of that really quick. Out of the way. Okay, for example, 482 divided by 2. If you list your multiples, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. Now, if you notice, these are nowhere near the 482. So what we have to do here is we have to think about these in the multiples of tens and hundreds. For example, if I break this down, I can look at this. If you cover up your 82, what do you see? You see a 4. Well, I know that's not 4. That's 400. I know this is not 8. That's 80. And I know that's not 2, but that is just 2 by itself. Okay? It's in the ones place. So I can break 482 down like this. Even though I do not have 400 on my multiples list, I do have a 4. I do have the 8. And I do have the 2. So what I ask myself is, 2 goes into 4 how many times? 2 times. And I bring my zeros up. 2 goes into 8 how many times? 4. Bring my 0 up. 2 goes into 2 how many times? 1. My answer is 241. It's the same concept, but you have to use your number sense of the value of the digits where they lie. Sometimes it can be more challenging because you don't have those numbers, but I do not recommend listing out the multiples up to 482. You will be there for a while. So hopefully this video helps. Thank you.